So for me, sort of why an academic career? Well, I think that it is an opportunity to have multiple kinds of impact on the world. One of the things that drew me was the opportunity to have such intellectual freedom, right? And what's not to like about a career where part of the career is that you learn new things all the time?
Recent surveys have shown that actually an American employee on average spend about 2,400 hours of their lives waiting in the traffic, which is about 4 months of your life. The main two controllers that we have, one of them is fixed time, which most of you have seen probably. More than 90% of intersections in the United States are operating under fixed time, where the signal timing plan, as it sounds, it's fixed. Or most of the case, it's pre-time based on time of the day. The other more recent one and more advanced one is the adaptive or feedback controllers, where in real time you can adjust the green allocation, the offset or cycle length or parameters of the traffic signal controllers based on the measurements or the detections that you have from sensors and cameras. How do I model it? I go after it using a differential equation. Why? Because traffic has dynamics, right? So the queue length on each link is changing. It's not static, obviously.
Unfortunately, there has already been a lot of vulnerabilities in these fixed-time traffic control systems with wireless capabilities that have been discovered. And these traffic controllers have been implemented in all across the United States and many different countries. What's important here in the switch-defined system are the coefficients, AM and BM, which we can use to determine whether a state is potentially stationary or not. If a state repeats after a cycle, we can consider that as a potentially fixed state or a stationary state.
This study looks at the impact of introducing a level of autonomous vehicles to freight operations. So for this, I use microscopic simulation, as I mentioned. The primary objective of this stage of the study is to quantify traffic improvements associated with the deployment of autonomous vehicle. And with that, we hope to assess the need for additional infrastructure. We saw that under the cooperative adaptive cruise control operation, we can reach speed gains of up to 30%. 0.3 and 0.5 seconds provide similar speed gains. And we can also conclude that traffic improvements associated with the deployment of autonomous vehicles are equivalent to those associated with the addition of one lane.
So basically, very recently, I'm interested in this smart transportation less security. So basically, in this study, we performed like a first software security analysis by looking at the code of the intelligent traffic signal system, which is ISIC for short. What do you want to do with this kind of systems? What are the goals, right? So one thing is that, okay, how about causing congestion? So this whole system is designed for reduced congestion. How about we just revert that? And then the second thing is that how about we actually can do something called personal gain. Basically means that, okay, let's say we, as a attacker, we can actually minimize our own travel time. When I hit like a red light, I can always turn it to the green light as fast as possible. But of course, this is at the cost of the other vehicle's travel time. So this is what we found. So basically, we found lots of these vulnerabilities in the traffic control logic. Basically, the data from even one single attack vehicle can actually greatly manipulate the traffic control.
PhD students have a fork in the road coming up as you get your degree. Practitioners rely so much on the research that comes out of that, and then we get to implement it.